Today we're going to be looking at the polygon angle sum theorem. So a polygon is a closed plane figure, so it's two-dimensional, with at least 3 sides that are segments. So there's 2 different types of polygons. We can have a convex and a concave. Convex, here are some examples of a convex. So meaning any of our diagonals we create in a convex, they will always be inside our polygon. Concave, here's some examples. These are concave because we can create diagonals that actually fall outside of our polygon. Let's look at some names of common polygons. We have 3 sides, it's a triangle. 4 sides would be a quadrilateral. 5 sides is a pentagon. 6 sides is a hexagon. 7 is a heptagon. 8, octagon. 9 is a nonagon. 10 is a decagon. So those are the common polygons we are going to be looking at and using. So let's name this polygon. Based on its size, 1, 2, 3, 4, 5. This is a pentagon because it has 5 sides, but it's also concave because I have a diagonal that falls outside of my polygon. So if I also want to name it, I can name this A, E, D, C, B. I have to make sure I go in the correct order, whichever way I start. So let's identify the vertices. Remember, vertices are our points. So the vertices, we have A, B, C, D, and E. The sides of our polygon, we know there's 5 sides because it's a pentagon, so we have side AB, which is a segment, BC, CD, DE, and EA. So our angles, we should also have 5 angles. So we have angle ABC, angle BCD, angle CDE, angle DEA, and angle EAB. Alright, let's look at example 2. We want to classify the polygon by its sides and determine whether it's concave or convex. So this we have 1, 2, 3, 4, 10 sides. Since we have 10 sides, this is a decagon, and it's going to be convex. So in this one we have 1, 2, 3, 4, 5. 5 sides, so it's a pentagon. And it's going to be concave because we have a diagonal that forms outside of our polygon. Polygon angle sum theorem. So if we want to find the sum of all the interior angles of our polygon, we would use n minus 2 times by 180. Whereas n stands for the number of sides of our polygon. In a polygon exterior angle sum theorem, all our exterior angles add together and they equal 360 degrees. A regular polygon has both equal angular, so equal side angles, and it's also equilateral. Alright, we want to find the sum of the measure of the interior angles of the figure. So I want to figure out what my interior angles all added together will be. So if I look at this, we have 1, 2, 3, 4, 5, 6, 7 sides. So in order to find the interior, I'm going to use my polygon angle sum theorem. I know I'm working with 7 sides. So now I'm doing 5 times 180 degrees. So if I add all my interior angles of this polygon, they're going to add up to be 900 degrees. The sum of exterior angle of a 15gon is going to be 360 degrees, based on that theorem. So let's find the measurement of an interior angle, meaning one interior angle and one exterior angle of a regular hexagon. Remember, regular means we have same side lengths and same angles. So first let's look at the interior angles. Regular hexagon has 6 sides. So to find my interior angles, I'm going to do 6 minus 2 times by 180. So 4 times 180 is 720 degrees. So all my 6 angles added together in my hexagon will be 720 degrees. But what we also need to find is just that one interior. Since we know it's regular, it means all angles are the same. So if I divide this by 6, each interior angle is 120 degrees. So if I added 120 degrees 6 times, I get 720. So now we know exterior angles add together to be 360. But we have 6 exterior angles, we want to know 1. So if I divide by 6, we find that our exterior angle is 60 degrees. Alright, let's look at our last 2 examples. We want to find the measure of angle A. So right now we're working with a pentagon. We know a pentagon has 5 sides. So my insides will be 5 minus 2 times by 180 degrees. 5 minus 2 is 3, and 3 times 180 is 540. So that tells me that all 5 of my interior angles should add up to be 540 degrees. So I need to first find this missing interior angle. So that means 104 plus 118 plus 96 plus 115 plus x has to equal 540 degrees. So if I add all those together, I get 433 degrees plus x equals 540. So when I subtract that to both sides, I get that my missing interior angle is 107 degrees. So to find angle A, I know these two are supplementary because they form a straight angle. So 180 minus 107. My angle A is 73 degrees. Right, now we have to find the measure of x and y. So we know this angle is 124. We know y with it is supplementary because it forms a straight angle. So to find y, we do 180 minus 124. So we get 56 degrees. So angle y is 56 degrees. I know I'm working with a quadrilateral because there's 4 sides. So that means using our interior angle formula, I'm going to do 4 minus 2 times by 180. So 2 times by 180 is 360 degrees. So all 4 angles have to add together to be 360. So I have 56 plus 65 plus 125 plus x. 56 plus 65 plus 125 equals 246. So when I subtract that from both sides, I get my missing angle x. It's 114 degrees.